Welcome to EDU World Space.
Once again, welcome to a new problem. This time, you're given uh, that you have a mass of 70 kilograms and you're standing on ice with a rock, and the mass of the rock happens to be 3 kilograms. Your initial velocity before you do anything is 0 meters per second, and also the initial velocity of the rock happens to be 0 meters per second. So that's what's given. And then we're also told that once you throw the rock, um, it acquires a specific velocity. The rock itself is moving at, so this is you before you throw the rock, and this is, once the rock is moving, has an angle of 35 degrees with the horizontal, and it's moving at 12 meters per second. So the effective final velocity of the rock, strictly speaking, is the um, is 12 meters per second times cosine of 35. Because it's this component, the horizontal component, that's the one responsible for moving the rock in that direction. So when you throw the rock, we want to find out what your speed is. We don't know what your speed is, and so potentially you could be going in the opposite direction. We don't know, so that's what we want to find in this problem. And so that's the information we're given. It's a frictionless surface, so we'll use the law of conservation of momentum. Which compares the initial and the final momentum. So the initial momentum of the system equals to the final momentum of the system. You could switch it and say the final equals to the initial. It's the same thing. The final momentum of the system is your mass, MA, times VA final plus MR times VR final, and that equals to MA VA initial plus MR VR initial. But remember, this is going to be zero because the initial for both you and the rock is zero. And so if we want to get your final velocity, it's going to be VA final becomes equivalent to this one goes to the other side, and it becomes negative mass of rock times the velocity of the rock, and all of that has to be over ma, which is your mass. And so this changes the problem to negative. The mass of the rock is 3.00 kilograms times your velocity, which is 12 meters per second. That's the velocity of the rock in the horizontal times 35, and then all of your mass, which is 70.0 kilograms. Plug in the numbers, and you get to see that this one becomes, we can use a calculator for this. So 12 cosine of 35 times 3, and then divide by 70, and that gives us negative, because you're moving in that direction. That's the negative, that's the positive, so you're moving towards the left. So this gives you negative 0.4213 meters per second. That's your velocity towards the left, and you can see it's a very small velocity because it's the rock that's giving you that push or that momentum. Hope you enjoyed the problem. Feel free to send any questions and have a wonderful day. Okay, bye.